Hello, my name is Camille. I am a first-year graduate student in chemistry in the Angle Lab. And today, for the Scripps Research Community Symposium, I will be talking about stable nickel precatalysts. First of all, what is a catalyst? So in chemistry, a catalyst is something that lowers the energy required for a reaction to take place. So if you imagine that without a catalyst, a reaction has a high energy barrier, but in the presence of a catalyst, we can lower that energy barrier so that reaction can occur, as shown here, where on the left we have the starting materials and on the right we have the products, and the energy barrier is the line I just drew. In real life, you can imagine that your dishwasher is a catalyst because you put your dirty dishes in and they come out clean, but the dishwasher doesn't change in the process of the dishwashing, and you can use it over and over. And it takes a lot less energy to use your dishwasher than it does if you were to wash all your dishes by hand. And in the Angle Lab and in a lot of chemistry labs, transition metal catalysts are used. So the transition metals are all the metals seen here in blue. And as catalysts, they have a lot of special properties and they lower the activation barrier for a lot of reactions that are useful in various industries, such as the pharmaceutical industry. So some catalysts that my lab uses are seen here. The first one on the left is palladium acetate. This middle one is nickel cod, where cod stands for cyclooctadiene, which are these here. And on the right, we have a ruthenium catalyst, which is called a Grubbs second generation catalyst. And the only one we need to focus on right now is this one in the middle, the nickel cod catalyst. And just so that for your reference, nickel is this one right here that I'm highlighting in green. So what is nickel cod useful for? One example that our lab has shown is that you can take an alkene, which is a double bond like this, and in the presence of catalytic amounts of nickel cod, which means less than one equivalent per equivalent of starting material, which is this here, we can take an aryl iodide and an alkyl zinc reagent, and we can put the aryl group here and the alkyl group here. And we want our chemistry to be useful for the general chemistry community, because say you wanted to put an aryl group and an alkyl group on your alkene, we want to help you do that. And the problem is that nickel cod is not a very good reagent for many labs because it's not stable in air. And so shown below here, if you take nickel cod and you just open it to the air, after 7 hours, it goes from being this pretty yellow color to being a little bit more orange. And after another day, it's almost completely decomposed so that you can't use it anymore. And for that reason, we store all of our nickel cod in our glove box, which looks like this. And this glove box has no oxygen in the atmosphere. So any compounds that are sensitive to oxygen can be stored there indefinitely. But as soon as you take them out, they go bad and you've wasted your catalyst. And so using nickel cod on large scale isn't possible. And so some of the chemistry our lab develops, and a lot of labs develop, can't be used on a large scale because nickel cod is one of the most popular precatalysts to use. So we had an idea. We wanted people to be able to use our chemistry. And so we resurfaced a complex, a transition metal complex that had been made in the early 60s called nickel cod DQ, where cod stands for cyclooctadiene, which is seen here, and DQ stands for duroquinone, which is the name of this compound here. And nickel cod DQ is an air stable complex that acts similarly to nickel cod. the yellow stuff I showed before, except it doesn't decompose in air. In fact, you can store it in air indefinitely, and it will work in your reaction. So how does one make nickel cod DQ? So you can start actually with nickel cod. That's one of the ways to make it, with one equivalent of nickel cod and one equivalent of duroquinone. You can combine them with a little bit of heat, and you can get out the complex in the end, which is easy. You can isolate it in air. So while you had to start with your reaction in the glove box, after the reaction, you can open it up to air, purify it as needed, and store it as long as you need until you want to run a reaction with it. What can nickel cod DQ be used for? Well, here is an example. So if we look below on this figure, we've shown the comparison of nickel cod with nickel cod DQ for a variety of reactions. And all of these reactions are taking an NH and an aryl chloride and converting it to an NAR bond. And these products are shown here. And in a lot of cases, nickel cod DQ actually performs better than nickel cod. For example, in the reaction I've already highlighted, nickel cod results in a 91% yield of the desired product, and nickel cod DQ results in a greater than 99% yield of the desired product. And the yield is the amount of product that's made based on the amount of starting material you put into the reaction. Can nickel cod DQ do everything that nickel cod can do? Well, unfortunately, it can't. And that's some of the current work that's going on in our lab is we are looking at ways to improve nickel cod DQ or make other versions of nickel cod DQ so that every reaction you could want to run that would involve nickel cod, you could just do with nickel cod DQ. And so if you think like a chemist, you would say, well, nickel cod DQ has these methyl groups here. Maybe we can change those methyl groups to something else and see how that affects the properties of the catalyst, the precatalyst that comes out. So you could imagine you could put some other groups here. You could imagine that you could just put groups here, for example. Or you could imagine you can change the backbone of the other ligand completely and use something like this is called a cyclopentadienone. And thank you so much for watching. I hope you enjoy and that you learned some chemistry today. Thank you.